Welcome to this explainer. Today, we are diving into something literally earth-shattering. We're looking at a project with a staggering scale. Egypt is quite literally moving the historic Nile River deep into the western desert. We are talking about one of the absolute most ambitious water infrastructure and agricultural reclamation projects on the planet right now. It's a massive endeavor, and it's designed to fundamentally reshape the country's geography, stimulate incredible economic growth, and lock in national food security for generations to come. Okay, let's kick things off with one massive number, 170. That represents a 170-kilometer artificial river that is being built right now. Just try to wrap your head around that for a second. For the first time in history, we're going to see the Nile essentially flowing straight through the western desert. And listen, this isn't just a pipe. It's a colossal 170-kilometer man-made artery of life. Its whole purpose is to completely transform a historically arid, dry landscape into a vibrant, massive agricultural hub. Here is our roadmap for the explainer today. We're going to cover the new artificial river, the engineering behind the water intake, the tunnels and lift stations, the smart agricultural infrastructure, how the new delta compares to Tushka, and finally, how all of this is permanently transforming Egypt's map. Part 1, the new artificial river. So, to understand how you actually green a desert, you first have to understand the sheer mind-boggling logistics of moving a river. Let's trace the water's exact journey. Step 1 is the initial intake, right at the Rosetta branch of the Nile. From there, Step 2 violently pushes the water through these sprawling, incredibly large diameter pipeline networks, specifically designed to transport water over vast distances. Step 3 transitions into the Tahaya Masir Open Canal, which is also known as the Eastern Transport Corridors. And finally, Step 4 delivers this life-giving water all the way to its ultimate destination, out at the Dabaya axis, deep in the western desert. Moving on to Part 2, engineering the water intake. Now, it's one thing to draw a line on a map. It's an entirely different beast to physically pump millions of cubic meters of water out of a natural river without completely disrupting the local ecosystem. The journey begins at this colossal intake station, located specifically in the Manashi al-Haganya area, near Menchat al-Qanater. This site wasn't chosen by accident. It was perfectly positioned to tap into the Rosetta branch. And right now, this location is an absolute hive of massive civil, electrical, and mechanical engineering works. It's really the beating heart of the entire New Delta project, acting as the primary gateway for the water's long journey into the desert. And the planned daily water capacity here is just mind-blowing. The system is starting with a capacity of 7 million cubic meters of water every single day. But as the project expands, this intake is engineered to scale up to an astonishing 10 million cubic meters per day. Just to help visualize that massive scale, that is the equivalent of thousands of Olympic swimming pools moving straight into the desert every single day. It is an almost unfathomable amount of water being redirected to fuel new agricultural life. Section 3, tunnels and lift stations. So moving water across a country that's already heavily developed means you are inevitably going to run into some massive logistical hurdles. To bypass major existing landmarks, the engineering teams had no choice but to go underground. You have 10 massive crossing tunnels working alongside 30 giant lift stations. These tunnels are absolutely critical for navigating under major obstacles like the Qattara Road, the Bahira Canal, and various railway lines. Imagine the absolute nightmare of excavating under live railways and highways without stopping daily life. Instead of disrupting the country's existing infrastructure, this artificial river literally just dives right underneath it. The sheer mechanical complexity here is staggering. Let's look at the pumping power. 30 giant lift stations, evenly divided with 15 in the northern sector and 15 in the southern sector. Why so many? Because they have to manage severe elevation changes in the desert terrain. They essentially work like a massive relay race, passing the exact same water up steep inclines. Each station is built with a daily capacity of 7.5 million cubic meters just to keep the immense flow moving. And naturally, they require a huge accompanying energy infrastructure just to power the pumps lifting all that water uphill. So who exactly is building all of this? Well, the Egyptian government brought in the heavy hitters, Hassan Alam, El Swedi, Orascom, and Concord. To meet the aggressive deadlines and get this complex system fully operational, these companies were officially directed to completely double their labor force and their equipment on site. And this massive mandate isn't just about speed either. It heavily stimulates local economic growth by directly employing thousands and thousands of workers on the project. Part 4. Smart agricultural infrastructure. Okay, so we've successfully moved the water. Now, how do we actually use it efficiently? Well, the desert is being outfitted with state-of-the-art infrastructure. Phase 2 is all about completely modernizing farming with smart irrigation networks and massive pivot irrigation installations. Crucially, and this is a huge environmental benefit for the region, traditional open canals are being replaced with safe, closed pipelines and concrete-lined sectors. This ensures that precious water isn't lost to evaporation under the harsh desert sun or just seeping away into the sand. Add to that brand new internal road networks and service buildings, and you basically have a high-tech farming oasis. Section 5. New Delta versus Toshka. As it turns out, this artificial river is actually just one piece of a much larger, two-pronged national reclamation strategy. The reclamation is happening on two massive fronts. Look at this breakdown. Down in the south, Egypt is expanding the Toshka spillway to reclaim 1.1 million acres of land. Meanwhile, up in the north, this new artificial river we've been talking about, the one feeding from the Rosetta branch, powers the New Delta project. And that project targets exactly double that amount, an incredible 2.2 million acres of targeted crops. When you add those together, you get 3.3 million total acres of newly reclaimed, fertile agricultural land carved directly out of the harsh desert. This isn't just some minor expansion, folks. It is a radical leap forward. By cultivating these millions of acres, Egypt is strategically insulating itself. It's creating an ultimate shield against global food supply chain shocks and effectively ensuring long-term national food security. And finally, Section 6, Transforming Egypt's Map. We are quite literally witnessing a geographic rewrite in real time. Because here is the ultimate takeaway. This single, unprecedented megaproject expands Egypt's total agricultural land by a staggering 30%. Really think about that for a second. A civilization that has relied almost exclusively on a narrow green strip along the Nile for thousands of years is suddenly increasing its cultivable footprint by nearly a third in just a few short years, entirely within the Western Desert. It's incredible. It leaves us with a truly fascinating question to consider. How will permanently shifting the flow of the historic Nile into the deep desert redefine the future of the nation's geography and economy for generations to come? The sheer scale of the engineering, from those 30 massive lift stations to the 10 subterranean tunnels, prove that when necessity demands it, human ingenuity can literally move rivers. Thank you so much for joining me for this explainer. Until next time, keep learning.